Today's lesson is going to be on polynomial multiplication. So we have some examples here of what we're talking about. We're talking about situations where you have a binomial times a binomial, like x plus 2 times x minus 5, or 2x plus 7 times 4x minus 9, or our third example is a trinomial times a trinomial. So I'm going to assume you're very comfortable with a monomial times a binomial, where we're talking about the distributive property. So that'll be an assumption here. We're not going to actually spend time in this video on that. So yesterday we looked at adding and subtracting, so therefore today we're going to look at multiplying polynomials. Now you might have been taught this in Algebra 1 as the FOIL method, and what FOIL stands for, as you can see on the right, is the first, outer, inner, last. It's telling you a method for multiplying these two binomials together. And so what the FOIL is saying is, it's saying you take your first term in each binomial and multiply them together, giving us x squared. Then you take your outside terms. The x and the negative 5 are on the outside, making it negative 5x. Then you take your inside terms, which would be 3 and x on the inside, giving us 3x. And your last term in each binomial is 3 and negative 5, giving us negative 15. So that's where the term FOIL comes from. It stands for first, outer, inner, last. If you were taught that method and you're comfortable with it, go ahead and stick with that. When you do get here, you need to make sure we're looking at our answer here, noticing that we have negative 5x and 3x. From yesterday, we should recognize those are like terms, and so we always have to combine our like terms. So we put negative 5x and 3x together, making negative 2x. So our final answer ends up being x squared minus 2x minus 15. Now, I don't generally teach the FOIL method because the FOIL method is somewhat limited. It only works for a binomial times a binomial. So I like to think of it more as the distributive method. Now, when we say the distributive method, that's I put that in quotations, you notice, because it's not technically distributing. And so the math purists out there are going to say that's the wrong use of the language, but I've found that's the way that students remember it best, is to think of it as distributing, just like you do the regular distributive property, where we have to distribute, rather than just one term, we have to distribute both terms from the first binomial through the second. So we have to take our first x times another x, our first x times a negative 5, and so you notice it looks a lot like the FOIL method. It's just another way to think about it. You have to multiply x times both things in the second binomial, giving me x squared minus 5x. Then we have to do the exact same process with 3. We multiply 3 by x, and we multiply 3 by negative 5. And so it's just another method, another way of saying the same thing. FOIL is just a shortcut way to remember it. Bigger picture, though, I think it's important that we understand what we're doing when we're multiplying a binomial times a binomial is we're taking each term from the first binomial and multiplying it by each term from the second binomial, then combining our like terms to get the answer. You see, all the work, everything looks exactly the same. It's just different wordings for it. I would like you to stick with whatever you're comfortable with. If you are comfortable with FOIL, stick with FOIL. If you're more comfortable thinking about distribution, think about distribution. Just make sure you're comfortable with the process of multiplying binomials. To continue on here, we're going to look at a couple of special cases for multiplying binomials. When you look at our first special case, we're talking about perfect square binomials, when you have 2x minus 6 squared. Now, first of all, it's important that you realize that does not equal 4x squared plus 36. That is a very common mistake. You cannot just square everything on the inside. Because when we think about what a square means to take something times itself. So we have to actually write it out as 2x minus 6 times 2x minus 6. Then we get into our FOIL or our distribution or whatever you would like to call it, where we have to do 2x times 2x, giving us 4x squared, 2x times negative 6, which is negative 12x squared, and that line is incorrect. We have to take our negative 6. We've already distributed our 2x all the way through. So we have to take our negative 6 times 2x, giving us negative 12x, and our negative 6 times negative 6, which is 36. So therefore, when we go to put that together, we have 4x squared minus 24x plus 36. If you look at your original mistake answer there, that's partially correct. You end up with your first term and your last term correct, but that middle term disappears because you didn't account for the distribution process or the foiling process. So our second special case is called the difference of two squares. Now if you look at this situation where you have 2x plus 5 times 2x minus 5, you notice that our middle term here, our middle sign is different. We have a plus and a minus, but everything else is the same. You have a 2x and a 5, a 2x and a 5, one's positive, one's negative. We call that the difference of two squares. So when I go ahead and FOIL that out, 2x times 2x is 4x squared, 2x times negative 5 is negative 10x. 5 times 2x is 10x, and 5 times negative 5 is negative 25. So in this case, those middle terms do end up canceling out because you have a negative 10x and a positive 10x that makes 0. So you're left with 4x squared minus 25. So that's how we're going to do our multiplying binomials. We're just going to simply distribute or use the FOIL process and then combine our like terms. Our last example here is multiplying trinomials. Now I'm going to show you two different methods for doing this. The first one is we can follow the exact same concept we used when we multiplied binomials. This 3x squared needs to multiply by everything in this second parenthesis. So I take my 3x squared times negative 2x squared, 3x squared times 4x, and 3x squared times 5. And you see the result down here. And I have to do the same thing for my 8x, multiply it by all three, and finally do the same thing for the negative 9, where I have to multiply the negative 9 times all three things in the second parenthesis. And you can start to see this gets really, really long, and it gets difficult to keep track of some of our terms. It creates a situation of disorganization. And it will work once I get my multiplied out, my distributed out answer. I can simply combine my like terms, put my x to the fourths together, my x to the thirds together, and my x squareds, my x's, and my numbers. And so this will work. This is something that a lot of people use. It works very, very well. I personally prefer the following method down here, method 2, where we're going to create a multiplication box. And what that multiplication box does is it simply organizes your thinking. Many of you have organizational issues just like me. And so by putting a multiplication box here where you notice we simply take the problem, 3x squared, 8x, and negative 9, that's our first trinomial, negative 2x squared, 4x, and 5. They go on the sides of our boxes, and it becomes a multiplication table where we take 3x squared times negative 2x squared to get negative 6x to the fourth. We take 8x times negative 2x squared to get negative 16x to the third. Now you'll notice our results from method 1 here are exactly the same as the results that are in our box. But our answer that's in our box is much more organized, and it also sets up one thing very nicely. When you go to do your answer, we have negative 6x to the fourth. Then look at your x cubes here. They fall in a diagonal. So your like terms end up all being on diagonals. So it really helps that organizational process. When you go to write out your final answer, all you have to do is add together the diagonals. So you get negative 6x to the fourth, negative 4x to the third, 65x squared, 4x, and negative 45. Those go together nicely. It's simply an organizational tool. You are welcome to use it as you choose. Alright, so this is our multiplying stuff. You are going to need to make sure you can do all those types of problems, binomials times binomials and trinomials times trinomials. We'll see you tomorrow.